right, so in the first learning objective, we learned the properties of limits and limits of certain functions by using the direct substitution. So now we're going to develop and use a strategy for finding limits. Let's start. All right, here's a strategy. It's called functions that agree at all but one point. And let's say like we have the function f to start with, and the limit point is given as x equals c. And if you can find a function g that agrees with f at every x but not the limit point in an open interval containing the limit point, and also if you know the limit of g at c, then you can say something about the limit of f. Again, even though f is not even defined at x equals c, that limit is determined, this limit here, limit of f, is determined by the limit of the g function for which we know something about. Okay, so let's go with an example just to see what kind of functions could be like good examples for this case. And here's an example. It's a rational function, x cubed minus 1 divided by x minus 1. So f of x is equal to x cubed minus 1 divided by x minus 1. The limit point is equal to 1. So if you go ahead and use the direct substitution to evaluate this limit, let's see what's going on here. So this is equal to 1 cubed minus 1 divided by 1 minus 1. And that takes you all the way to 0 over 0, which makes this limit undefined as is. But the question is, well, this function obviously doesn't have x equals 1 in its domain. That's why we ran into 0 over 0 case. So what else can we do? Can you find another function that would be the same as this rational function for every x except x equals 1? Okay, so what can this function be? Well, we know from algebra that we can simplify this quantity. And I'm going to use this formula in the algebra formula card. Let me just tell you what it is. So this formula here, okay, x cubed minus a cubed is equal to x minus a times x squared plus ax plus a squared. Again, this is the algebra formula card. And check again. All right, going back here, x cubed minus 1 can be rewritten as x minus 1, x squared plus x plus 1. Therefore, this expression here is equal to, and you cancel out, divide out x minus 1, you have x squared plus x plus 1. That's in fact what we call g of x. And you can see that it's true that f is equal to g whenever x is not equal to 1. If you go ahead and use your calculator, you will realize that the graph of f, which is this rational function here, x cubed minus 1 divided by x minus 1, and if you graph x squared plus x plus 1, you will see that those graphs match except x equals 1, because this rational function is not defined at x equals 1, so we have a punch here. And this one is defined, so that's why it's filled here. So these two functions match everywhere except x equals 1. So therefore, I can use this result here saying like the limit of f is equivalent to the limit of g by the same dividing out business and using this factorization from the algebra formula card. Okay, so therefore, we know the limit of g at x equals 1 because it's a simple polynomial and direct substitution works. So we essentially substitute 1 for x and you get the limit value to be exactly equal to 3. So the limit of g is equal to 3, so is the limit of f. All right, here is a strategy for finding limits. You can take a good recipe in that regard. So first item is talking about learning to recognize which limits can be evaluated by direct substitution. So if you have a polynomial trig function, transcendental function, or rational function, where the limit point is nice enough for you to substitute c for x and getting a real number in the output. So that means direct substitution works perfect. So then you don't need to do anything else, okay? And second, let's say like the limit of f as x approaches c cannot be evaluated by direct substitution because you get like maybe 0 over 0 type situation. So then you're going to try to find another function that agrees with the given function for all x, but not x equals c, which is the limit point. So the limit of the function can be evaluated by the limit of g, for which you know how to find the limit by direct substitution. And if none works at this moment, use a graph or table of sample values to reinforce your conclusion. All right, we are done with this learning objective in this video. Please watch the next video to see what I'm going to say for the dividing out technique, which is an algebra technique. All right, thanks for watching. Bye.